Good morning, class. Today we're going to do lesson number 20, and this is going to be lesson 22 out of 25. So I finally figured out, with like 2 weeks ago in the lessons, not the course itself, that we're going to do 25 total lessons and 25 total assignments. So um, you can kind of count up how many assignments you have left to complete, and you can see the finish line now that there's going to be 25 of them. And I got confirmation today that there's going to be no final exam for this class. So we're just going to have these projects or these little assignments. And the last one, 25th one, is going to be a bit longer, maybe take you an hour, might be a bit more work, might be like 10, 12, 20. No, I'll cap it at 15 questions. It would kind of just be like general review for you to do. And I'll weight a bit more than the other assignments. So let's jump into the lesson today. So last class we looked at we looked at sine and right angles. So I thought today we'd look at the other two trigonometric ratios, cos and tan. So just to remember what we did last time, we talked about sine and how we have to have a right triangle for this to work. So a right triangle means that we have a 90-degree angle shown by this box here. So with cos, we're going to look at the adjacent side divided by the hypotenuse side. So the cos of the angle, so cos is a function, so cosine, which is C-O-S, of the angle is going to equal the adjacent over the hypotenuse. So if you look at the triangle here, hypotenuse is always the longest one. C, opposite is going to be A, is going to be the one across from the angle. And B, the adjacent one, is going to be the shorter side that touches the angle. So looking at cos, it's adjacent over hypotenuse. So let's look at this example. Now this is an example right from problem 4 on page 224. We're just finding a different length. Instead of finding the height, we're finding the length here. So if you're having trouble with problem 4 on page 224, look at this one and then you can go back and try that one again. So we have an angle of 29 degrees and we got a hypotenuse of 7 feet and 3 inches. Now 7 feet and 3 inches, it's hard to do anything with that because it's not in 1 unit, it's in 2 units, feet and inches. So let's convert our inches to feet. So we have that 12 inches equals 1 foot, meaning that 1 inch equals 1/12 of a foot. So we just divide both sides by 12 to cancel out 12 on the left side, getting 1 inch, and we're left the fraction 1 over 12 feet. So now converting 3 inches, we're going to replace inch with 1 over 12 feet. That's going to be 3 times 1 over 12 feet, giving us 3 over 12, which is going to be a quarter, 0.25 feet. So hypotenuse is going to be 7 plus 0.25 feet, giving us 7.25 feet long. So that's the length of hypotenuse. So I made a mistake here. I thought it was hypotenuse over adjacent, which wouldn't make sense at all. So cos theta is going to equal your adjacent over your hypotenuse. And I'm pretty sure last video I was saying hypothesis the whole time, so sorry about that. So our adjacent, we don't really know what that is. So our adjacent is going to be our x value. And a hypotenuse is going to be 7.25 feet. So we can figure out what cos of 29 degrees is. And what I'm going to do is I'm going to show you on my calculator how to calculate that again. So we want to make sure that we're in degrees. So I don't know if you can see that there. That means degrees. If it says RAD, we're in radians, we're going to get a different value. So let's make sure we're in degrees. If you are in degrees and you're not too sure how to change it, you pretty much want to change mode. So you want to hit mode. So you have to like second function mode or even degree. Play around with those values. You might be able to get it. If you're having real trouble, let me know. So we're going to do cos of 29, and that is going to give us 0.874. So if we're trying to find an angle, we want to keep a bunch of digits. But if we don't need to find the angle, we only need to keep like 3 or 4. So we're going to say cos 29 degrees is going to be 0.875. And what we're going to do is to find x, we want to get it by itself. So we're going to times both sides by 7.25 feet. So on the right side, we got 7.25 feet on the top and 7.25 feet on the bottom, and they're going to cancel each other out. So pretty much you're just dividing them and you get 1. So you get x times 1, which is just x. So then on the left, we got 7.25 feet times our 0.875, giving us total distance of 6.34 feet for our x value. So that's going to be the length of the adjacent, the length of x that we want to find there. So that's cos. theta. So let's look at tan theta now. So tan is a really interesting one. So we don't use hypotenuse at all. We use just the opposite and adjacent side. So tan theta is going to be opposite over adjacent. So looking at example 2, we have, we're trying to find theta, and we're given each of the side lengths. So we're given the hypotenuse of 5 meters, opposite of 3 meters. So again, the opposite is right across from the angle, and the adjacent at 4 meters. So we can use each of the 3 trigonometric ratios we know. We can use tan, cos, or sine. So we're going to do all 3. So tan theta is going to be opposite over adjacent, so 3 over 4. And what we're going to do is we're going to use the inverse tan of that fraction. So on the calculator, how we're going to do that, if I stop sharing for a second, we're going to do second function tan to get to that tan -1. So if you hit second function, you can do the yellow text. So we hit tan -1, and then we're going to put in our 3 over 4. So because it's a fraction, what I'm going to do is I'm going to put brackets. Oops, oh, I did it backwards. How do I delete? This is what the problem. Okay, so we'll do brackets. We'll go boom, boom. And then in the brackets, oh shoot, is that right? No, I mean that's right. In the brackets, we're going to put 3 divided by 4 equals, and then we're given our angle of 36.9 degrees. Let's see if I can share my screen again. A lot of back and forth today. Oh, that's not what I wanted to do. Oh, yeah, that is what I wanted to do. There we go. Okay, so that is how you get your angle of 36.9 degrees, and that is going to be theta. So each of the other 2 methods we use should give us the same value. So looking at cos theta, we say, okay, cos theta is going to be your adjacent over your hypotenuse. So it's going to be 4 meters over 5 meters. So we're going to use our inverse cos again. Now, if you don't have a calculator that has the inverse cos, if you're using your phone or something, we can use arc cos. So it's the same thing as doing cos to the -1 or arc cos. So I recommend using Wolfram Alpha, which is just a website you can go to. So if you just type in Wolfram Alpha, bring you to this sign, and you can just do arc of cos, and we'll put 4 divided by 5 in there, and we'll just specify that we want degrees. So it can give you 2 values, radians or degrees. Radians is just a different value or a different measurement system, but we want degrees, so we get 36.87, which is exactly what we got before. We just rounded up to 36.9 degrees. So that arc, A-R-C, and then the cos or the tan, or a sine even. So let's go back to our notes. So both cos inverse and arc cos will do the same thing, and we're going to get the same value. And we can do the same with sine, where sine is your opposite over hypotenuse, so 3 over 4 meters, and it's going to give us the same angle. So all 3 methods work, and you can, in this problem, you could have chose any one. You didn't have to do them all. You could choose any one that you're more comfortable with. Let's look at example 3. So here, we're given one angle and one length. So we know the hypotenuse, and we know the angle is going to be 20 degrees. So I just went ahead and label my hypotenuse, capital H, is going to equal 14 meters. Adjacent, capital A, is going to be my x value. That's right across, or adjacent, sorry, is the one that's touching the angle. And my opposite, the one right across, is going to be my y value. So sine theta is going to be opposite over hypotenuse. Cos theta is adjacent over hypotenuse, and tan is opposite over adjacent. So you can choose x or y to start, but let's choose x. So let's figure out what x is. So we have the adjacent. So the 2 functions that have adjacent in them are cos and tan. But with tan, we need to know the opposite as well. We can't have 2 variables. We only have one variable, one unknown. We don't know what a is. We don't know what adjacent is. And we don't know what opposite is. So tan won't work. So we need to use cos. So we have your adjacent x over your hypotenuse 14 equals cos of 20. And then I'm going to times both sides by 14 to cancel out 14 on the right side, giving us 14 times cos 20 equals x. And cos 20 is going to be 0.9397. given us about 13.16 meters is going to be your adjacent length, or x equals 13.16 meters. So now let's find the opposite. So we could use sine here because we want to find the opposite, but we have the hypotenuse. Or we could use tan. We now have the adjacent. So let's use tan just so we have practice using tan. And again, we're going to replace x, the adjacent, with 13.16 meters. And again, multiplying both sides by 13.16 meters. And this gives us that our y value, or our opposite length, is going to be 4.79 meters. So you have to do two different calculations for this. So there is a problem in the homework that's very similar to this. So please look at this again as an example on how to guide you through that one. If you have any questions, as always, please ask. Hope you all have a great day, and I'll see you next time.